Horizontal projectile motion. We say is the projectile motion which a body is thrown horizontally from the starting point. We need to note the following when we are dealing with horizontal projectile motion. The angle of projection will always be 0. When you are told that the angle is projected horizontal, that implies the angle of projection is considered to be 0. And this is the diagram which is representing the horizontal projectile motion. Here we are having our vertical distance y, maybe from a cliff or a building. And here we are having our horizontal distance x from a cliff to a point where the body is striking the ground. And we have initial velocity v naught. The angle between the initial velocity and the trajectory here is considered to be 0. Time of flight. We obtain the time of flight from our usual equation. Y is equal to v naught sine theta plus a half gt square. Now, when we say time of flight, means we are going to put angle of projection is equal to 0 here. Sine of 0 will make all this term to be equal to 0. Now, when you make t square the subject from this equation, we are going to obtain the time of flight is equal to 2y. This 2 will come to this side. 2y you divide by g. Therefore, this equation represents the time of flight for the body projected horizontally. Horizontal range. The horizontal range is given by x is equal to v naught cos of theta t. X is equal to v naught cos of theta t. And t is the time of flight for the horizontal projection. Therefore, here you may substitute the square root of 2y over g at this point. Angle theta is equal to 0. Therefore, cos of 0 is equal to 1. We may say the horizontal range covered by the projectile in a horizontal projection will be given by v naught times t. Instantaneous velocity. This is the velocity at any point in the trajectory. Is given by v is equal to square root of vx square plus vy square. We get vx by taking v naught times cos of theta. Angle is 0. Therefore, cos of 0 is equal to 1. 1 times v naught, we get v naught. Therefore, here vx will always be equal to v naught square. And vy is equal to v naught sine of theta plus gt. Sine of theta means to be sine of 0. Angle of projection on the horizontal projectile motion is always 0. Therefore, sine of 0 will be 0 times v naught will be 0. All this term here will disappear. Therefore, vy will be equal to gt, will be substituted in the part of vy square. The angle of instantaneous velocity makes with horizontal is given by tan of theta. Tan of alpha is equal to vy divided by vx. Remember, this angle alpha is the angle at any point within the trajectory of the projectile. Projectile on an inclined plane. Now, in solving the projectile on an inclined plane, we have one important concept to note. We are going to resolve G into horizontal and vertical component. And the component which you are going to get is the horizontal component will be equal to G sine alpha, which has no effect in any calculation. And the vertical component will be GV is equal to G cos of alpha, which will be used in our calculation. Now, this is the diagram which is showing the projectile projected on the inclined plane. This is our inclined plane, OBC. OBC is our inclined plane. And there is an angle alpha, which inclined plane is making with its horizontal. And here we are having G. G is vertically downward. Therefore, the G will be resolved into two components. The vertical component will be G cos alpha, and the horizontal component here will be G sine of alpha. The angle alpha we are referring is this angle here. The angle of projection with horizontal or C is called theta. Now, the angle of inclined plane is alpha. Therefore, the angle of projection here will be equal to theta minus alpha. We take the angle from trajectory to the ground minus the angle of the inclined plane. The remaining value here will be our angle of projection. Therefore, wherever we are speaking about the angle of projection with the inclined plane, with the slant of the inclined plane, we'll be taking theta minus alpha. Therefore, this is V naught here is initial velocity of projection. Now, we say let theta, the angle of trajectory makes it horizontal, alpha, the angle of inclined plane. Therefore, the angle of projection will be equal to theta minus alpha, time of flight. We use this equation to get the time of flight. That is SOY is equal to UT plus a half AT square. When we solve this equation, after solving this equation, we are going to get 2t is equal to 2v naught sine of alpha, sine of theta minus alpha divided by g cos of alpha. Now let us check out to get this equation. Therefore, the time of flight on the inclined plane, we have said is obtained from the equation S is equal to UT plus a half AT square. Now, when we are saying the time of flight means the time from the launching point to the landing point. At the landing point, the vertical distance will be equal to 0. S here represents the vertical distance, will be equal to 0. And the initial velocity, U, will be equal to V naught, then sine of angle of projection. Now, if you refer the angle of projection with horizontal, you are going to use theta. But if you refer the angle of projection with inclined plane, we are going to use theta minus alpha, like that. Then we multiply by t. We add, we subtract a half. Now here we are going to consider the vertical component of gravity, which is equal to g cos of alpha. G cos of alpha. All this one you multiply by t square. Now, making t the subject, we are going to obtain a half a half G cos of alpha T square is equal to V naught sine of theta minus alpha, we multiply by T. T will cancel with this T here. If we make T the subject, it will be equal to T is equal to 2 V naught sine of theta minus alpha in brackets, we divide by G cos of alpha. G cos of alpha. Now this one will represent our time of flight. We write it as capital T is equal to V naught sine of theta minus alpha, you divide by G cos of alpha. This is the formula for time of flight when we are considering the horizontal projection. Range on inclined plane. Range on inclined plane. We are going to solve the range on inclined plane by two stages. The first stage, we shall first calculate OC from our diagram above. We are going to check where OC will be given by V naught cos of theta times T. T is time of flight. Then we are going to substitute our time of flight times cos of theta divided by G cos of alpha. Now, the range, you are going to use trigonometric relation to solve for R. We say R will be equal to OC divided by cos of alpha. Substituting OC from our above equation here, we are going to get V2 times V naught square sine of theta minus alpha times cos of theta divided by G cos of squared alpha. Now let us check how to obtain this equation. Now from our diagram of a body projected on inclined plane, we had an inclined plane like that. We say this is angle alpha. We say this is angle alpha, and here we indicated like that. This point we called it B, and this point we called it C, and this point we called it O. Now, this is the range we are looking. We say this is R. This is R, is the range we are finding. Now, by using trigonometric relation, since we are having OC here, we say cos of alpha will be equal to OC, you divide by R. R is our range. If we make R the subject, we get R is equal to OC divided by cos of alpha. But what is OC? If we refer the body projected from point O and then landing at point B, and this body is having initial velocity V naught. Remember, the angle of projection with the horizontal here, from here to OC, this angle from trajectory to OC, we called it alpha. Therefore, if we want to check this distance here, OC, if we want to find this distance here, OC, we are going to say the horizontal distance, OC, will be equal to V naught, which is the velocity of initial velocity of projection, times cos of theta, which is this one, times time of flight, which is from O to B. Now, our time of flight, we have already derived here. We just substitute. Therefore, we say OC will be equal to V naught cos of theta. We multiply by this equation here. 2 V naught sine of theta minus alpha, then in brackets G cos of alpha. This is the value of OC. But from this derivation here, we can substitute OC with this equation here. Therefore, we get R will be equal to V naught times V naught will be equal to 2 V naught square, and then sine of theta minus alpha, sine of theta minus alpha. I multiply by cos of theta, cos of theta, and then all this equation I'm going to divide by G cos of alpha, which is this one. Then I multiply by cos of alpha. Which is this one. Multiplying here the denominator, we get R is equal to 2 V naught square sine of theta minus alpha, then cos of theta, we divide by G cos of squared alpha. Get that? Therefore, this will be the range on the inclined plane. Maximum height on inclined plane. We use the relation V square is equal to U square plus 2AS. Now, at the maximum height, the vertical velocity V will be equal to 0. And the initial velocity will be equal to V naught square sine of squared theta minus alpha minus 2 acceleration. Here we are going to put G cos of alpha. We multiply by S, which will represent maximum height, which is the vertical distance. Now, making maximum height the subject here, we are going to get V naught square sine of squared theta minus alpha. You divide by 2 G cos of alpha. Remember, theta minus alpha is the angle of projection with the slant line of the inclined plane. Theta is the angle of projection with the horizontal or ground of the inclined plane. Alpha is the angle of the inclined plane. Uses of projectile motion. The first use during flights. Food, aid, and other supplies may be dropped by plane. When they are dropped, we say they follow projectile motion. Second, during war, shells from the mortar follow projectile motion. They have calculated horizontal distance, calculated the angle, and calculated velocity so that they can strike the enemy. Use number 3, in a football match, the ball is kicked at a certain angle, must follow a projectile path in order to score a goal. Thank you for watching.